Dear students, so let us discuss the mechanical properties of the solid. Chapter number 9. So in the previous chapter we have already discussed the rotational motion chapter. We have discussed about the rigid bodies, and where we have seen that the rigid body is having a particular shape and its shape cannot be changed. The shape should be fixed. But if we are coming to the practical experiments, or on the practical concept, if you are considering, you know that we can change the shapes of the materials. Even if you are considering a strong aluminum rod, by exerting a particular amount of force, you can change the shape, or you can bend that rod, isn't it? So the concept of the rigid body is not that much valuable in the practical life. So before that, just recall what was the rigid body. So rigid body was an idealization of solid body in which the deformation was neglected. The deformation means changing the shape or changing the dimensions, length, area, volume. That means, in other words, that it is given, that is the distance between any two given points of a rigid body remains constant. The particles or the system, suppose if you are considering a system of particles, that means in a rigid body, the particle displacement or the distance between two particles in a rigid body system will always be a constant. It means even if there is an external force is exerting upon this rigid body, then also the particle distance will become or will be the constant only, the same only. But in real life or in the practical life, the bodies can be stretched, or we can bend that bodies, compressed. That means the solid bodies are not perfectly rigid. So they can be, we can bend or compress, elongate or stretch the mechanical or the bodies, the solid bodies. That means we cannot confirm that all the solids are rigid bodies. According to the concept of the rigid body, the solid or the body should not undergo any deformation. Okay, that means the distance between two particles always will be same only. Now, the forces that we are considering, that means the deforming forces. What are the deforming forces? So the deforming force is the force which have the ability to change the shape or the dimensions of a particular solid body instead of changing its position. Okay. In the initial chapters we have seen, that means the Newton's first law of motion. If you are exerting a force, that will causes the motion, or that will become the reason behind the movement of the particle. So here, this deforming force will not be providing any movement. Instead of that, the deforming force will be helping, or deforming force is being the reason behind the change of the shape or the dimension of a particular solid body. That's why such forces are known as the deforming forces. Now, according to the behavior of a particular solid body to the force exerted upon it, the bodies are divided into two categories, which are elastic bodies and plastic bodies. So then we have to consider what is the elasticity and plasticity. So elasticity, suppose if you are considering a rubber band, if you stretch that rubber band, then afterwards if you are removing that force, the force exerted for stretching that rubber band, what will happen? It will come back into its original shape. As well, if you are compressing a spring by exerting a particular amount of force, and thereafter if you are removing the external force that you have applied, then that spring will regain its original shape. So that means as you are exerting that force, either compression or the stretching force, then what is happening? There is a restoring force it is generated in that particular body, maybe in the case of the rubber band or in the case of the spring. And as you are removing that external force that you have applied, the restoring force will help that particular body to regain or regain its original shape. So the property of a body by virtue of which it tends to regain its original size and shape when the applied force it is removed is known as the elasticity, and this deformation is known as the elastic deformation. So example it is given, that is rubber band as well the springs. All such things are the examples for the elastic bodies, and that particular phenomenon is known as elasticity, and the deformation it is known as elastic deformation. The deformation, that means the shape change that happened for that rubber band when you have stretched it is known as the elastic deformation. That means at the time when you are removing that force, it will regain its original shape. Now let us come to the plasticity and the plastic deformation. Consider the china clay. So that means the clay which is used to make the clay materials like the pots and all those things. Okay. If you are exerting some force upon a china clay, suppose consider a china clay cube, okay, or a sphere which is made up of a china clay, and you are applying a force upon that particular sphere, then the shape of that sphere will change. According to the force, the direction of the force that you have applied, the shape will be changes. And afterwards, it cannot regain, or it couldn't regain its original shape. Means after you are exerting the force, the deformation is happened, and the deformation will long last. It cannot regain its original shape after you removed that external force also. Still you removed even if you remove the external force, but that deformation will long last. It cannot, the body cannot regain its original shape. That phenomenon is known as the plasticity, and such deformations are known as the plastic deformation. And the ideal elastic materials are difficult to manufactured, but at that time ideal plastic materials are there. The mud, putty and all those things are the ideal plastic materials. Now the elastic materials, it is given one rubber band. When you are not exerting any force, the first figure it is showing when you are not exerting any force, its original shape is there, and now you are compressing it. At that time the rubber piece, it is getting compressed, and there exists a restoring force, and which is against or which is in the opposite direction of that compression force, and as you are removing that force, that body will regain its original shape. And afterwards the third figure it is showing elongation, the stretching force. You are applying a stretching force, and as you are removing that force, it will regain its original shape. Now let us come to the elasticity and plasticity and the reason behind these two phenomena. For that, the spring ball analogy is given. Actually, in the solid, you may have studied that systems, the solid system, the structure of the solid system, the cubic system, and that categorization of that solid means the particle distribution inside a solid that you may have studied. Means if you are coming to the atomic structure, that means a particle it is constructed by the combination of atoms. So in between these atoms, the bonds will be there. So here these bonds will act as the spring. So as you are compressing, or as you are applying a deformation force, the deformation will happen, and the bonds, actually the displacement or the elongation in the bonds or the change in position of the bonds will happen, and as you are removing the external force or the deforming force, these bonds will regain its original shape and length. So that's actually happening in the elastic materials. In the plastic materials, this, as you are changing the shape, that means the structural, internal structure it is changing, that means the bond length, the variation in the bond length it is happening, but that bonds cannot regain its original shape. So here, with the help of the spring and ball analogy, it is well defined here. So you can see, for solids, all the atoms are bonded to each other by interatomic or intramolecular or interatomic or intermolecular forces. And in the chemistry chapters, you may have studied that the atoms inside a solid, the atoms are having or they are vibrating at their position itself. So as you are exerting and deforming force, this interatomic distance will change, and it means that the elongation in that bonds will happen, and there exists or there will be the generation of along with the generation of a restoring force, and the restoring force will help the body to regain its original position. And but sometimes this will not be happen. This will not be happening. That means the restoring force will not be there in the bonds. In such cases, the body will remain in the state of that deformed, in the deformed state. The body will remain in that deformed state. Now let us come to a new term, that is stress. Stress is actually the restoring force per unit area. The restoring force, okay, per unit area in a particular body, it is known as the stress. Actually, force by area is actually the pressure. So stress is actually having the unit and as well the dimension of that of the pressure. And here the force in consideration, it is actually the restoring force. That is why this one it is known as the stress. So restoring force per unit area developed inside the body. When a deforming force is acting upon it is known as the stress. And the SI unit, it is Newton per meter square, and it is known as the Pascal. Newton per meter square, which is known as Pascal and is represented by the symbol Pa. And there are two types of stresses. One, it is the normal stress, and next one, it is the tangential stress. So two types of stresses are there: normal stress and as well the tangential stress. Now let us look in detail regarding the normal stress and the tangential stress. This normal stress it is happened maybe due to a compressive or a stretching deforming force. So this compressing, if the force it is exerted, it is compressive deforming force, then that stress generated will be, that is stress, it is the restoration force per unit area. The stress will be known as the compressive stress. That means when there is decrease in dimension, the length it is decreased due to the compression. So that shear or the stress generated per area, it is known as the compressive stress. And if elongation or the stretching it is happening, then it is known as the tensile stress. That means increase in the dimension. These two are normal stresses. And these stresses are acting perpendicular to the cross-sectional area of the body. Cross-sectional area of the body, in which direction that or in the opposite direction which the deforming force it is exerted. That you can measure. Actually, the shearing stress which acts in the opposite direction of the deforming, or the shearing, the restoring force it is actually acting in the opposite direction of the force. It's a deforming force that you have exerted. So the stress will also be acting in the opposite direction of the deforming force. Now the next one, it is the tangential stress. Here this tangential stress, it is not a kind of elongative or a compressive or a stretching force. It is not a stretching force, and as well a compressive force. Instead of that, this tangential stress will change the shape of the body. Changing the shape of the body. And it will act tangential to the surface of the body. Parallel to the surface of the body. And that's why it is known as the tangential stress. So when a deforming force acts tangential to the surface of body, which causes the shear stress, and the strain formed, it is the shear strain. So a new term we had, that is strain. What is the strain? So stress we have seen three various types of stresses. The two various types are there: normal stress and as well the tangential stress. And in normal stress there are two types, that is compressive stress and as well the tensile stress. Now let us come to the strain. Strain is actually the ratio of change in dimension to the original dimension, which is called the strain. The ratio of change in the dimension. As you are exerting a force, a deforming force, then definitely there will be a change in the dimensions of the particular body or particular solid body. So the change in the variation, which whatever the amount of variation happen, either in the length or in the area or volume, we are comparing that with the original length, area or volume. That means the ratio of change in dimension, change in length, area or volume to the original dimension, length, area or volume, is called the strain. Or it is known as the fractional change in dimension. Fractional change in dimension is also known as the strain. Actually, if you are considering the strain in the case of the length, if the deformation it is happened in the length, if you are considering, then the changing the length divided by the original length. So if both are having the units meter, then meter by meter will be there. That means the strain is not having any unit. Strain is actually a unitless quantity. So the dimension also will not be there. Actually, for the strain, there is no units and dimension. But in the case of the stress, the unit it is Pascal, and dimension will be that of the pressure. So the equation for strain, it is actually change in dimension. Suppose if you are considering length, L1 and L2 are the two lengths, then L2 minus L1 divided by L1, that is L1 it is the initial length, and after the deforming force you got the length L2. Suppose an elongating force, that means L2, it is get elongated. So the L2 minus L1, that you can represent it by delta L, the change in length divided by the original length, that is actually the strain. Now the strains are of three types: longitudinal, shear and as well volumetric strain. The longitudinal strain is actually change in length by original length. Means the normal stress, the strain which is formed due to the normal stress, either compressive or elongative, stretching, either compressive or the stretching forces. So the change in length divided by the original length, that is known as the longitudinal strain. Now let us come to the shear strain. Shear strain is actually due to the tangential stress or the tangential force. Means the displacement of the face divided by height of the face. Displacement happened for the face, that means one face it is changing. The bottom portion of the face will not be changing. Upper portion, suppose if you are applying a tangential force or tangential deforming force upon a particular body, the lower portion which is in contact with the surface will be remain as it is, and the upper portion will deform. The change in upper portion will be happen. So the change in that faces, edges of that faces, that divided by the height of the face. Now the next one, that is the volumetric strain. Volumetric strain, from the name itself you can understand, that is the change in volume per original volume. Now let us come to the Hooke's law. Hooke's law states that for small deformations, if the deformations happen it's very small, then the stress and strain are proportional to each other. That means stress by strain will be a constant. And this constant, the proportionality constant K, which is known as the modulus of elasticity. Hooke's law is an empirical law, and majority of the objects are following this Hooke's law. Then also there are some exceptions. So Hooke's law states that the stress by strain will be a constant, and the constant, it is known as the modulus of elasticity. And there are three types: Young's modulus, shear modulus, and bulk modulus. That portion we will discuss in the coming section. So read the textbook. This much portion you read the textbook, and as well go through the previous chapters, exercise, question and answers. If you are having any doubts, ask me. Okay, thank you.